Hello, it's Michael here. Welcome back to the teacher commentary to the Joy of Code. Today I'll be talking about what I did in the last couple of episodes, that is the episodes 4 and 5, where I introduced method calls and if statements. And I will talk a little bit about the reasoning behind the scenario being as it is, that is the trick the turtle scenario, and a couple of alternatives of what you can do or what you may want to look out for. Let's have a look at the scenario. Here is the trick the turtle scenario open that I have used for the last couple of episodes. This is in the state as we left it, where if we look at the editor for this, by the way, I just did a double click on here. I don't think I said that in the episode. I said you can right click and open the editor. Double click on the class also opens the editor. So we had the state where we had a move method call and an if statement with a turn, and the effect of that, as we have seen, was that it moves forward and when it gets to the edge turns around. One thing to note is that I have stuck in the animal class here. That is a common trick for a teacher in very early examples. So when you want to introduce very early examples where you don't have a lot of technique available yet, where the students can do very little, sticking a class here between the actor class and the class in which students work is a very nice way to provide some code to the students, and then you can have a fairly fine-grained control over what level of complexity you expose to the students. For example, the reason that I did this here is to get this add-world-edge method. The add-world-edge method is not built into the Greenfoot environment. The move and turn methods that we're calling here, they are both built into the Greenfoot environment. They are always there. They are here in the turtle example inherited from the actor class. The actor class is built into Greenfoot. That will always be there in Greenfoot, so they will always have the move and turn method. But the add-world-edge method does not exist in the built-in actor class, and I wanted a method here that returns a boolean that I can use in an if statement. So I have provided this method just for this particular scenario to the students. And the way to do that, one very nice way, is to stick in another superclass, in this case animal, and put the code there. What this does is it gives you the ability to provide some ready-made code, that is some ready-made methods like the add-world-edge, to the students without the students having them cluttering up the class they write. So the class that the students work in is the turtle class, and that is fairly short and easy, so they see only the code on the screen that they are working on. So you don't need to stick the add-world-edge method, the definition of that method, into the turtle class, because that becomes distracting and confusing for the students. You can put that into a superclass. That's a very nice thing about object orientation, that you can divide up your code between different classes, so you can move all the code out of the way that you want students to have available to use, but not to modify. So one way to do that is to have the animal class. It gives you very fine-grained control over what you want to expose to the students. For example, what I could have done here in the animal class, by the way, when I showed that in the episode, we switched this to the documentation view. In the in the Greenfoot editor, you can switch between viewing the source code or viewing the documentation. The documentation shows standard Javadoc format, and this is generated dynamically from the source code. So as soon as you change the source code, if you change the comments or the methods, this will be represented here. If students only are expected to use these methods, looking at the documentation is enough. They can just look at the method signatures and see there's add-world-edge and see what they can do. I would have had a choice, for example, if I want to make it even easier, and if I choose, for example, not to introduce parameters on the very first day, I could have provided here a move method, public void move, without a parameter. And then the implementation of this method is just, say, move 4 steps forward. So I could have provided, say, a move without a parameter in the animal class. And if I do this, and I compile this, then I have available here in the turtle a move method without a parameter. So I can then compile this and put that in, and the turtle moves. So as a teacher, you have very good control by writing the class in whichever way you like to decide what kind of concepts you want to expose to the students. So you could get away on the first day, for example, without dealing with parameters at all, if that is what you want to do. In my case, I have decided dealing with parameterized methods on the first day is okay, so I don't need to include this. But I have included this method here to have a very easy introduction to an if statement. An alternative would have been, if I don't want to have this superclass here, for example, when I introduced it, I had this very brief discussion of inheritance to explain, where these methods come from. If you don't want to do that and you don't want to use the animal class, you could get away without this method by doing something else. For example, instead of turning at the world edge, I can use a built-in method of Greenfoot. I can, for example, use keyboard input. I can write if Greenfoot dot is key down left. What this does is the is key down method checks whether a specific key on my keyboard is being pressed down, and then there's a parameter defining which key I'm checking. Left is the name of my left arrow key of the cursor keys. Every key has a name, and this method is in the Greenfoot class. It's a static method in the Greenfoot class, so that is why I have to write this Greenfoot in front of it. So this one is also a possibility to introduce an if statement. Could have done this. If we try that out, I have removed the method without a parameter. This, by the way, let me just do that again, compile that again. This is what it looks like in Greenfoot when you get an error. We haven't seen that yet before. Well, you may have seen that if you played around yourself, but I haven't demonstrated that. So there's an error message down here. And of course, I now have to put the parameter in again. So if I compile this, put my turtle back in, now it runs straight, and when I press my left arrow key on the keyboard, the turtle turns. In fact, it's the wrong way around. Now I'm pressing the left key and the turtle turns right. But you can now easily introduce keyboard control by saying, okay, if I press the right key, it should turn 7. If I press the left key, it should turn -7. So now if I put the turtle in, I can now, with my keys on the keyboard, control the movement of the turtle. This is actually a very nice thing. You get full keyboard control very, very quickly. That is actually something that we will do in one of the next episodes very soon. But that also is an opportunity to use this one for introduction of if statements. The disadvantage is, compared to what I have done, or what I actually see, at least see as a disadvantage, is that you have 2 more concepts here that you introduce at the same time. Because here we are calling a method that is actually defined in another class. So we need the class name in the dot notation. And in fact, this is a static method. That's why this is actually a class name, not an object name. These are all concepts that I will explain in one of the coming episodes. So here is a method being invoked that comes from another class, which is something we haven't seen before. And there's a string parameter to that method, which is something we haven't seen before. So if I use this example to introduce if statements, if you have bright students or students who have a bit of programming experience, so that would be fine. But it is harder than the example I have chosen because of those 2 additional concepts of having another class involved and having a string parameter to this Boolean method. That is why I have decided not to do this, but it is a viable option. You may want to do this. So I have decided, that's why I have decided to stick in the animal class, to have available here a method that is inherited into the turtle class so that the turtle has it available itself. It has no parameters and it returns a boolean. That's the kind of method I wanted to demonstrate in my if statement. One other example that you could use for introducing an if statement is a method also from the Greenfoot class, which I can't demonstrate because of a technical problem, but I'll show you what I mean. The Greenfoot class has a method called getMicrophoneLevel, or getMicLevel it's called, that gives you the level of noise coming into the microphone. So if I say if Greenfoot get, and if you're not sure what the method is called, there is a code completion for methods. If you hit Control Space, if you start typing a method and you hit Control Space, you're getting a pop-up menu with all the methods that begin with those letters. So there is getMicLevel. That gives you an integer between 0 and 100. So if I want to say, if there is a little bit of noise, I can say if Greenfoot getMicLevel is greater than 4, for example, so it's if there is some kind of noise coming in, then turn. That makes a very, very nice classroom demo, because what you're saying is the turtle goes straight, and then when you shout at your computer, it turns. And if you do that as a demo in class, you can program this and then you can get all your students to shout out, and every time they start to cheer, the turtle turns. It's a very nice example. Unfortunately, it has one problem on macOS, why I can't show this. There is a bug in Java with Java on macOS with USB connected microphones, where this doesn't work very well, and the microphone I'm using to record here at the moment is a USB connected microphone. So with my currently connected microphone, this is actually buggy and doesn't work very well. That is why I don't usually do that when I'm running on a Mac. On Windows, it should work fine, and if I use my built-in microphone on my laptop, it also works fine. So that is another example of a simple if statement, how you could get started introducing an if statement. But again, it is a bit more complicated than the example I have used, because again it uses a method from a different class, from the Greenfoot class, and it uses a comparison operator here, the greater than already, because this method does not return a boolean, it returns an integer, and so to get a boolean out of it you have to compare the value to something. So these are alternatives, but as I said, if you want to make the life for the students very easy at first, use a superclass here and give them something that is very easy to use, like the @WorldEdge method, which I have defined so that it is in the turtle class and it returns a boolean and takes no parameters, so it is as simple as possible. So I have reduced the number of concepts for my very first example, and then I can introduce string parameters and comparison operators and external method calls and so all over the next few episodes, and that's what I'm going to do. Having this superclass here, typically I do only for the very first example. Students very quickly come up to scratch to the point where they can use the built-in methods directly. It is not necessary for very long to simplify the Greenfoot API, but for the very first example, this is a good technique to use. Alright, that is all I have to say for these episodes, and then I'll see you back again after the next one. Okay, thanks for listening, bye bye.